Hello from your favorite artist electronist, Mr. Q12. So in the last video, I mentioned that I'm using the full output of this chip, meaning 16 numbers or digits to drive. It cannot drive more than 16. This is the maximum. And I mentioned that I started to make this board. I also show it in the last video. This beginning, when I mentioned that I started it like this, I wanted to make it more nicer with equal pads and large pads, easy to access pads, but then I changed my mind and I repurposed this scrapped pads, if you want. And here I didn't have exactly the number that I needed here, so I put this little board from whatever, and here as well. This is from a very old board. These are peeling off very easily if I'm not careful. If I'm holding my iron too much on them, if the heat is too much, it will peel off. I have to be careful with that. And here is a beauty shot from an angle. And here is the actual continuation from the last movie. The first thing I thought I should try is to link all these displays in parallel. All the A, B, C, as you can see here, A, B, C, D, decimal point are going into the chip, but underneath they must be in parallel. Only these pads and also this, they zoom up to 16. They get their individual pin of the display. But these ones here are going in parallel. They are linked in parallel onto A, onto B, onto C, and so on. So this is what I'm showing you here. Here I made a mistake actually, and I wasn't aware because I thought this is pin 12. So all these are wrong linked. But what I'm showing you here is how I link them in parallel. So this pin to this pin that I thought at that point in time. I should actually put a picture. All right. Okay, so I just made the picture of the diagram I was keeping in front of me, and I was looking on it. You see these markers? I thought this is pin 12 here, then 9, 8, and this is 6. You can see them here. 12, 9, 8, and 6. This is a mistake I made in the first round, but it doesn't really matter because I changed my mind. I took them out and I remodeled all this thing because I kind of tested here how to ensemble it pretty much, how to link them in parallel. And here you can see this yellow blob. This is a melting plastic that you put in a pistol and you squish it, you melt it with heat. And it's very good actually. It's adhering very well. Indians likes to use it a lot in their movies when they are building a lot of stuff. But I'm not really too attached to this method of gluing with this kind of melting plastic. I'm cutting little bits from it and I'm putting where I need it. That's why I'm having this used blob here. It's terminated. Instead of throwing it away, I'm cutting little pieces and I'm using them, especially here when I'm using this kind of pads. This and this are glued with that kind of plastic, and it's very good adherence when it's cold. It's like cement. It's very, very good. It's not flying away. It's tested in time, is what I'm saying. That's what I used here. You can see these blobs of brown liquid like a glue, and also especially here a larger blob. Okay, this is another shot where I'm showing how it's looking from this side, and it's like shit. It is like shit. I didn't like it in this form because I cannot distinguish, I cannot control the wires not to short out between the pins. So it's linked here from this pin, is going between these pins, and I put a bit of that melted plastic here to hold it in place, not to move around, not to jiggle, not to give it a chance to make a short with either pin, because these are very, very small dimensions, what I'm playing with. Right now, when you are seeing it zoomed in, you think is a good amount of tolerance, but in reality it's very, very small distance between the pins. So this wire, I stabilize it with this blob of melting plastic, and then it's catching to this other pin, and from here I made it a couple of turns, and then I continue. It's a very long wire actually. Then I continue it again between these two pins, not to short them. This is not a wire, this is actually a strand of melted plastic that it got like that. It's looking like it's a wire, and it's a bit confusing. Everything is confusing, not only this part here. That's another reason that I didn't like this procedure, but I tested it. I totally dismantled. I took out all these wires, I melted their connection, and I took them out. Each of them, I also took out all these blobs of melted plastic with my knife. I just, press it and it peeled off. A bit hard. In this way, I tested the adherence of this plastic, and I can tell you it's quite good adherence. But it's looking very, very unprofessional. If I'm making a short, for example, I have no idea, I have no control. Where the fuck is the... I cannot follow it. I cannot see it. It's too much. It's like a jungle already, and I didn't linked all the pins. There are only 5 of them, 1, 2, 3, 4, and 5, and that's it. And I have 8 of them, and it will be extremely agglomerated with all 8 in the end. Trust me on that. So this is the next level. The next day, when I took out everything, and I actually reused these wires. I didn't cut them or throw them away. I literally reused them here because they were already formed around the pin with that little circle. I only had to remelt the solder and push them on the pin. But this time I tested the module before starting wiring, and after I tested the module, I realized I made a mistake here, and then I made on the back of this little paper card that I'm using, this is the back of it, I remade the numbering. As you can see, here is 12 on the left side. When I'm turning back, the module is on the other side. While here, you see the markings, here is the pin 12. This was the mistake. I put the pin 12 like you are seeing it on the front because I was looking on this diagram. But here, I tested the display in real life and I realized the mistake and I made this diagram after I tested. Here I actually numbered them. That is 12, that is 7, and the same here. This is 7, this is 12, you see. And this is the bottom part where the wires are coming out. How I constructed it, I cut a cardboard with ears for the lateral. Here is the lateral side. Also this lateral side as well. This one and this one. So it's a cardboard that is catching, is bending on those lateral sides like a box pretty much. And then I cut a hole, a small longitudinal hole like this for the pins for each of them. I measured where they are fitting and I cut them. So this is a full cardboard that is glued on the margins, okay? Only here in the middle is not glue on anything. Here is flapping. The cardboard is quite thick and is not flapping that much. Yeah, and then how I linked the parallel wires is I linked them as before, like here, but then I put this paper on top. I secured the entire length of the wire with paper that I glue it. Simple paper, not anything special. And also, you can see them, that paper here and here is like molded, like forming. I made the shape of the wire. I actually scribble until I find the wire underneath and press the paper onto the wire pretty much and onto the surface that I was gluing it. For each wire is a piece of paper that is catching the wire and is keeping the wire in the position I want to control. This is the control I wanted to be very sure is not making shorts with those two pins. And you can see the wire in the middle. I made the same procedure like here where the wire is starting from this pin, is going between these pins and then is catching to this other pin and then between these pins and so on. And here is the same thing, probably is from this pin like this, and you can see the wire. You can see underneath is going into that and then it's going between the two pins, these two pins, and it's going like that. And here again, back between these two pins and is linking there and then outside. The margin pins are the easiest to link. So you have to imagine here, this is the first module with its pins. This is the second module. This is the third module. And this is the fourth module. All right. So this is how you must see all these pins and the gaps between them. And here is a beauty shot from a side. This is the next step. I put some paper, not to flap around, not to move around, not to make shorts between them, because I was testing some modules and some pins again, and I was getting double segments. A couple of segments were litting in the same time. I was looking here on the board, where the fuck is shorting? And I was looking especially between the pins. And in reality, these wires here on the end, they were touching. Ah, motherfuckers. So that was a shitty experience. And it didn't took me long to figure it out, but I wasn't looking at all, to be sincere here. I was concentrated somewhere there. And then after I realized here, these motherfuckers are flapping and touching, then I decided to add a bit more strengthening. So that's what I did here. Also here, I also write and mark everything, but then I cover it with paper, so the markings are no more visible. Here you can number them 1, 2, 3, 4, 1, 2, 3, and this is the fourth here, because it's smaller wire, it's not longer like the other ones. Probably I reused that wire that was small. And in the end I catch it from here, from the top. The other ones, I catch them from the bottom up. You will see later. By the way, the work was insane. Was boring as fuck to link everything in parallel and to pay attention, not to short everything, to make it on the middle. Fucking hell. This was super hard. It was exceptionally hard. And here, this is where I put this new cardboard with new pads, and I linked all the wires onto the pads, and only this one from the top here. And if you are a good observer, you can see, so you see, this is a round. This wire was long enough to actually put it beneath, under this pad, and then going outside, and I made only one circle beneath this pad, and I soldered it here on top for each of them. Only this wire here, F, until here, and that's it, is stopping there. It wasn't long enough. And also this one, the decimal point, is not long enough. I didn't make it around these pads. How I put the wire under these pads, because they are pretty well secured there, they are bent underneath. You can see a marking here, is a marking on the cardboard. That's a needle marking. I inserted a needle under each, not under all at once, but each of them. I put the needle and I kind of make a hole with that needle, and then in that hole I inserted the wire and sewing. And this is from this other viewing with other illumination and other shadows. And this is another top view beauty shot. But this is the most important thing. You can see it is a bit raised up. This new cardboard also glued. Yeah, you can see this cardboard here, how is glued on the lateral here. And here as well, you can see it. And this is the next step. After I finished this front cardboard, I started to link these wires that are the 16 wires. But at this point, I have only 8 until here. I also marked, this is the 7-segment module, 1, 2, 3, 4. Only 4, remember here, only 4 of them I have, the grid pins, 12, 9, 8, and 6. So 1, 2, 3, 4, and is exactly what I'm having here. Is this longer lines that I draw here on the schematics. Yeah, this is the beginning, how I started. So I started with 1 here, and here is from the top. This is half of it made. So only 2 modules, only 8 numbers, pretty much. Initially, I marked everything here on the top, as you can see, 1, 2, 3, until 11 here. In continuation, 12 to 16 here. I had to number them here on the side, because here on the top everything was covered by the wires themselves. And this is another view where I'm actually showing the little remnants, the little cuttings when I desisolated all these wires. The table is full of them. Yeah, here is full, I believe, when it's completed with all the wires linked. By the way, zoom in. By the way, all these wires are catched. I rounded the end here, and I inserted that circle that I made from the wire, the hole, onto the pin. The same is for each of them. You see, here. Each of the wires are catching here with a circle. The wire is made as a circle. Originally, I was thinking to leave the long wire and to solder it along the pin, but then I changed my mind. I don't know why, and I decided to make a circle and insert it as a circle, and it remained like that for everything. This is chaos, actually. This is extremely chaotic wiring. I don't like it personally. I like more civilized and more clean wiring than this, but yeah, this is how I imagined actually it should work. This was my idea from the very beginning when I didn't started anything, when I imagined how I should make it in reality. So now when I'm seeing it in reality, it's not looking exactly as pretty as in my imagination, but this was the path. This was the direction I was thinking is possible to actually build it. And it's looking like crazy, but doesn't matter that. What it matters the most is that it's working. And that I managed to link all these wires without any shorts. I didn't have one shorting wire, with exception on those external ones that I secured them after that. But internally here, I didn't have absolutely no shorts. Here is another view directly from the top. Grid wires linked to their respective pins. Here, this is another beauty shot. This is actually very nice. And here is with the wires catched on the board. Finally, finally, trust me, this was not easy either to make it like this. It was hell. I worked like 2 days only on these wires to bend them in shape and drag them. One day I made this side, and another day the other side. For some reason, it took me 2 days. I was so bored, and especially bored from the parallel wires that I dragged on this cardboard before adding these other ones. It was hell. It was a hell of a project, but I'm very glad that I finished it, because I make it work. I used all the pins of the chip, literally all the pins. I used the entire functionality of the chip I'm using, and it's looking very interesting. I personally like it. I like it. Yeah, I forgot to mention on this board to show you the finesse of this wiring here. Look how crazy. It's crazy. It's very fine wire here. And I literally dropped some glue. This yellow thing that you can see here, yellow-orange thing, that something is spilled there. I literally drop glue on top of the wire to glue them in place, to glue them on the cardboard. I specifically distance the wires between them, not to make any kind of contact between them, especially here in this side where they are more close together. Here they have quite a good space between them, but here the last ones here are very, very close between them. So here I put more glue, and I specifically distance them. These other ones are not a problem, and also those ones. So back to the linking here on this grid wires. When I solder the pad to link this wire, these little wires that you are seeing here, they didn't snap off. They didn't spring out like usually they do, because I had this glue in place, and that glue form the wire and stick the wire and hold the wire in its original position that I bent it there, and they didn't spring out. They remained like they were built for that position to be, and this helped quite a lot. This was a very important detail while I was linking all this thicker and dangling wires. If I'm unsoldering these external wires that are coming from underneath, these grid wires, if I'm unsoldering one wire, it will spring out like crazy, like bam. That goes for each of them. I had to hold them with my tweezer on position, and with the other hand, I had to solder it and then wait to solidify there to cool down. And yeah, it was a little bit more harder to link these wires because they were springing out like crazy. These little wires staying on position and not springing out themselves, they helped a lot. That's the point of it. Here is another shot. I should have explained on this view. Actually, you can see the little wires that are coming here. Yeah, you see, and these are springing out like crazy here. They are a little bit because of this bending underneath. It's creating a very forceful springiness. By the way, this is the beauty shot again. It's very beautiful. And here I'm showing that the board was not completely paralleled with this other side, but in the end I solved this problem. I forced everything, all these wires, all these grid wires, the colored wires that you are seeing there. I forced them, and I leveled everything. I corrected this obliqueness. But I was showing that nothing is perfect. Even if it was remaining like this, nobody gives a shit, if it's a little bit like that pack. But yeah, I'm a perfectionist, and I'm trying to do my best, and I managed to level it in the end. I believe here I level it already. Immediately after I made the picture, I level it. So these wires are finished here, all of them, and also in this side as well. I actually started with this one, and then with that one, and then I continue with this second one, and then the second one there, third, and so on. So I worked in a X pattern to center, to balance the forces more easily on the board, not to be too skewed up. and that was an interesting approach, because that helped. Is what I'm saying. It helped to balance, to align this board on top of everything, and to bend more easily those first wires. That's what I'm saying. So here I'm preparing this little also scrapped jumpers. They were used in other boards, older boards, and I reshaped them as straight. But they were very, very bent, all sorts of shapes, and I rebent them, especially here on the margins. They were having like a hook like that to go under the board. It was very hard to scrap them out of their boards, and I have a ton of them actually. And they are very good on catching the solder on them and to hold the solder. Very good jumper wires. So here I made the first bend, and I tested that bending, the limits of it, how much is going up to here and how much is going here. And here I didn't care how long is going down, but I cared how long is going in this side. Here I bend them all with the same, relatively with the same length. This top length is for the top side here, and the longer length is for here. Here they are soldered, and here I put these green wires originally, but later I changed these wires, and I also added another negative wires here. I added later, but I don't have the picture, but you will see it in the movie when I will present it when it's working. This is how I linked everything here. It was a bit hard to link them like this, but it was possible. By the way, with this occasion, I'm telling you, if you really want something, if you put in mind to do something, imagine how you can make it, and after you find a way in your mind, in your imagination, how you can make it, then proceeding and making it is like 50% the work is finished. When you know the direction, you know the path, you know that you can do it, you know the way, the 50% of the project is finished when you know the way, when you imagine it, how you should link everything, how you should ensemble it. This is what I'm transmitting to you. You have to imagine everything how it should be made before you are making everything. When I was having the chip on the table and I was not having this board, I was not having anything built. I imagined everything. I planned in my mind how to build it. I imagined it, and I find a way, and this is the way I imagine it. I should link everything here, then drag some wires from underneath here. I thought a lot until I find this way of doing it, like you are seeing it here. I didn't think once, and I find the solution, and then I start building it. I thought many days how to link everything, and many hours. All right, so this is another view from the top, like that. Very beautiful. I have two capacitors here, by the way, on the power lines, on 0 volts and 5 volts. Here is a nicer shot on this very fine wires. You can see how they are bent in position, everything, and how they are glued on the cardboard here. Very nice. And also these ones, why not? The copper, how is shining. And that's it. This is the last shot on everything, how it's looking. This is number 2 chip, by the way, if you remember, that I tested everything last time. And I switched that first chip that I thought was burned. I switched it back, and I made all the tests in that test cardboard, if you remember. And this is the second chip that I use it on that test cardboard. And then I took it out from there and I repurposed it here. Finally, this is a final usage of this chip. So it was quite an adventure for these 2 chips, the first one and the second one. That's why you are seeing this number 2 here. So this is the story of the making of this module. And now let me show you the video of it. Already I have 50 minutes of explanation until here. Actually, let me switch to the programs. So I have here. So if you didn't watch my last video before this video, do watch it, because I'm explaining all these programs until number 9. But here, starting from 10 up to 14, so all these 5 programs, you see, they are specifically made for this 7-segment display is what I meant here, 4x4 modules. So this is the module. The entire module is quite small, you see, is this small. And here is how it's looking underneath, a little bit on the side. Like I told you, this is the wiring negative and positive here, and they are getting power from these 2 alligator clips. It's coming from there, like that, the little one, not the bigger one. The little one is the transformer actually, and of course it's modified. It's those traveler transformers, 1 amp 5 volts transformers types. Let's say it's a yellow wire. This is the negative wire that is coming from under this board, connected on the same pad with this negative black wire here, exactly on the same pad, and it's going into the negative on the ground pin, you see, GND. And this white wire and this other white wire is the in and clock wires. And here is showing that it's working. I leave this program to run like this from yesterday, so it's having approximately 24 hours of continuous working, literally all night and today, and I'm super happy about it. The chip didn't get hot. I just put my finger on the chip to check it right now, because I didn't check it until here, and I was thinking to actually check it if it's getting hot or something, because it's driving all these LEDs, and it is a little bit of amperage. Let's actually play all the programs. Perfectissimo. All right. Yeah. All right. So I prepared it a little bit. Now let's actually start to program it, starting with number 10, the first program to show number 8 and the decimal point on all 16 common cathode 7-segment LED display module. So let's starting it up. And this is the entire program. Very cool. And let's upload it. And hopefully no stupid errors. It's happening. Oh, perfect. And as you can see, all the decimal points and number 8 is shown, is displayed. So this was the first test to actually check if I'm having any wires or segments or grids interrupted. I was thinking this is the perfect program to show me if something is not wired correctly and is missing or shorting or something. And it's perfect. Now let's go to number 11 here. What this is doing, counter demo program from 00 to 999, using all 16 digits, each 4 modules of 4 digits to count in the same time. Not that fascinating, but I will play it. By the way, this is the entire program, not that one. And here it is, how it's working. Everything in unison is counting beautifully. Fantastic. I really like it. So that's 11. This is 12. Let's go to 12 here. So what this program is doing, counter demo program from 00 to 999 at different speed per each 4-digit module. And this is what you've seen. Let's upload it. When I started the video, exactly this program was running. So it's counting at different speeds. As you can see, this is already 200, 300, and this is 60 or 70. You see, this is slower, and that's faster. And it's kind of randomized in a sense this way, because when this counter, the top one, is reaching 999, it's starting from 0, but the other counters are trying to reach that 999, and it's kind of randomizing everything. Relatively pleasant. It's a pleasant randomization this way. So that's a number 12 program, testing program, of course. Number 13, this one. Random number generator. This is the program here. It's a bit of funky stuff. You can pause the video and look in my code and copy it if you want and apply it on your stuff. And let's upload it. Random number generator for each 4 digit of all 4 displays. Change slowly, one after another, interval 500 milliseconds. So that's the program. And here is the interval actually, 500 milliseconds, half of a second interval. Yeah. Oh, yeah, it's cute. It's a cute program. I wanted a random program. And this is the best random program I could think of. I thought on other random programs, I tested other random programs, but they were stupid, very, very stupid, and you couldn't discern, you couldn't understand what is going on. So this is the cleanest random program I could think to make. And this last one, number 14, decimal point animation, moving ends. So this is the program here. You can copy it if you want. Let's upload it. And I'm commanding only decimal points. Pretty cool. Pretty cool. I like it. I like it! So yeah, very, very cool. Extraordinarily cool project. I really like it. I'm very, very pleased. I'm very, very happy that I fucking finished this entire electronic module. And I'm very happy that I managed to check this chip completely for all its 16 pins. That was the main idea. That was the main desire, the main curiosity. I was extremely curious if the chip is doing what it's saying that is doing. And yeah, it does. It does. This is the proof. What you are seeing here in all these tests, it does what it's saying is doing. And that's glorious. That's perfect. That is awesome. The chip name, by the way, is it here? TM1640. This is the chip that I'm using right now and that I tested here today. And the next one, 1638, not 37, but 38, is the next chip that will arrive. This 1638. So this, you can see here, common cathode, like the ones that you are seeing right now, only 8 displays. Unfortunately, not 16. The common anode, only this 10 displays. It's a bit different. I wished I could drive 16, the same as my 1640, the one that I'm just using right now. This is using 16 common cathode. I wished I could find a common anode LED display chip to drive also 16 common anode LED displays, but I didn't find it. They are not commercially obvious. You cannot find them easily. I believe they have 16 common anode, not this one like you are seeing here, TM1638. I don't think this is the only chip that is having this maximum of 10 common anode displays. I believe they have the 16 version, but they are not publicly give it or make it available. Is my impression, of course. This is my way of thinking. I'm not trusting anybody in anything. I'm putting under question everything. So is my impression that they have actually this common anode with 16 outputs or even bigger than that. But they don't want to commercialize it for some reason. I don't know. It's only for the chosen, only for the important people somewhere out there, not for everybody like me or you. This is my impression, of course. Take it with a fist of salt. Don't take it literally, everything I'm saying. And this is it about this wonderful project and the programs. Let me make it full screen. So this is it about this project, about its problems, about this building. This video was about how I built it, all this entire module. And I'm telling you, it was not easy. It was quite hard. I had a lot of problems to solve. Most of all, I was forced to have a ton of patience and to check everything, every error that I had. And I did have errors. It worked from the first try, pretty much. The entire ensemble, the entire project, the entire module that I constructed here. It worked from the first try Yeah, well, I'm very glad from this point of view. But I did have some errors, not major errors, but some shitty errors. I was paying a lot of attention. This entire project consumed a lot of attention from my part, not to fuck it up, and it worked. It worked from the first try, pretty much. 1-0 to me. This is it. Thank you very much for watching. Thank you very much for listening to all my explanation and to all my details. And I hope you like it. Also, leave a like, please. Always leave a like. And see you later on my next movies, if I will make other movies. We will see. I'm curious as you if I will make other movies, because I'm starting to reach an end of an era for me personally. So yeah, we will see. I hope I can continue it, but how long and how many, hard to say. I don't know. We will see. Wish me luck, and also leave a like, and also show to other people what I built and what I made. Until next time, I say to you goodbye, auf Wiedersehen, sayonara, pocieciorne, and arrivederci, and salutare la neamuri. Mult pa! From your favorite artistic reference, Mr. Q12. Bye bye.